I just want to let you know that I won't go into detail to the federation architecture, because it's pretty much based on the context broker and the Hadoop solution. At the end, it's a context broker and Hadoop solution that are working on it. So I just want to focus on what it's beneath, on top of the network management system that I said before. It's Nagios and this federation layer, what I call the XIFI infrastructure monitoring middleware. Actually, this is more or less the picture that I presented before. More or less, we have different regions, different nodes, whatever we want to call it, with each one of them with the network management system. We set up these SIEM instances composed of the following adapter that I'm going to present right now, in order to adapt the layer between the monitoring tools, the proper probes on the monitoring system, and the federation monitoring, and also to link each other in interconnectivity monitoring. As a high overview, this is pretty much what is the XIFI monitoring architecture. In the below side, you can find what is expected that each one should be installed. Here you can see that we need 3 adapters, which is the network active monitoring, which is the NAM, network passive monitoring, which is pretty much for monitoring the switches and routers, I mean the network elements. But I mean, this component, it's a little bit ongoing, so I wouldn't go into detail. You will see it later. And DEM, which is pretty much for Datacentre and Enablers Monitoring. All those goes into the NGSI Adapter, which is pretty much for adapting the different formats. This is why we have some parsers, okay? And this will fit to the context broker and so on up to the federation platform, okay? Okay, I'm going to just give some hints of the different adapters. The NGSI Adapter, as I say, it takes the raw monitoring data collected by the different adapters like NAM, NPM, and DEM, to standardize and publish it to the federation generic enabler, the context broker. In order to make these adapters as much independent from the different modules, some parsers are used in order to standardize this format. For example, for NAM we have a parser, for DEM we have another parser, so it's a matter of collecting different parsers, and this way we have a common format which is defined by the NGSI. The NAM, which is actually like UPN we developed, is pretty much, as I said before, as for network active monitoring. Will enable us to check if quality of service and service level agreements are accomplished between different specific endpoints of the federation. Here you find more or less the high level overview, which is based on a couple of probes based on one-way delay and bandwidth. Okay, these probes are command line based, but we don't want that. We want to provide a web-based interface. So this is why we put on top of them, even though here it's in the right side, the measurement collectors, which are pretty much we can provide with it through web API. And all these measurement collectors will fit the NGSI adapter, as I said before. But as previously I showed you, we can, from a user interface, we can request directly these measurement collectors in order to request an on-demand test and to know what is the current status right now. So we can do all of this through this measurement collector. And as I said before, we can the core parameters are the bandwidth, which is pretty much the throughput, and latency. The DEM is in charge of gathering performance data from both physical hardware as well as virtual machines. And also we planning to monitor the different services deployed within the infrastructure, which means the generic enablers. This architecture, I just want to let you know that it's a bit deprecated, because the partner which is in charge of this component is working on a new version, which pretty much will the workaround is to skip the Nagios core and check the NRP plugins within each one of the monitoring machines and skip it and go directly through the NGSI adapter. I'm not going to into detail, but because the solution has to be discussed between the corresponding partners, but more or less I want to give you the hints. And the OpenStack Data Collector, which is quite simple. The Odyssey adapter collects capacity data, number of cores, size of memory, size of disk, a number of users from the OpenStack installation directly from the API and the command line. It pretty much could be enhanced in order to provide all the information to the rest of the monitoring system. And this OpenStack Data Collector goes directly through the NGSI, as I said before, in the general architecture. And the monitoring is pretty much seems simple. It's not, but it's working.